All right, I'm going to give you guys a brief video about equivalent forms using distributive property, and I hope it's quick, but sometimes I talk a lot. So here we go. If I gave you this problem, some students might be like, all right, I know exactly what to do to narrow that down into one number. I'm going to follow order of operations. And maybe you remember what that is, or maybe you don't, and that's okay. That's not really what this unit is about, nor is it really what I'm talking about in this example. But order of operations just tells us how to go about getting lots of numbers to turn into just one single one. And we have to always follow this procedure. I shouldn't say always, like sometimes there's mobility here, but we have to stick to a specific order. Otherwise, there'd be kind of chaos. So we decided that we should always start with P, which stands for parentheses. So if there's anything inside the parentheses to do, we do them. So since 5 plus 2 is 7, instead of writing 5 plus 2, I'm going to write 7. That's, again, the idea of equivalence, meaning same but different. 5 plus 2 is 7, so instead of writing 5 plus 2, I can write 7 in its place because they mean the exact same. So since I've done parentheses, then I move on to the E for exponents. There's no exponents here, so then I move on to multiplication and division, and that's what's happening here. 4 and 7 are being multiplied. There's no symbol, so that tells me that it's going to be multiplied anyway. That's what missing symbols are. And 4 times 7 is 28. So that's my final answer. Yay. Lots of numbers turned into just one single number. So the beauty of math is that you can do things in different ways. Different is good, right? So this is one way a student might do this. They might follow the procedure this way. But another kid might come along and say, well, you said that multiplication, like when there's parentheses, I can multiply, right? So there's a multiplication because there's a 4 and a 5 right there separated by a parenthesis. So let's do that. If we multiply 4 times 5, we get 20. Okay, and since that 4, not only is it attached to the 5, it's also attached to the 2 because both of those are in the parentheses. So if this is trapped this way and it's trapped here too, we have to kind of distribute that 4 to this and to this. So if I multiply 4 and the 2 together, this is a positive 4, this is a positive 2, and 4 times 2 is also a positive number. And now it makes sense to kind of add them. So notice these numbers add up. They match, right? So different, same exact answer in different ways. So this is what's known as the distributive property. You can take the number outside of a set of parentheses and multiply it into the stuff inside the parentheses. So since there are 2 things inside, there were 2 things to add up, and that's how I got my final answer. So this can be a little bit more complicated. I'm going to try this example here. So I'm going to take the thing that's on the outside, and I'm going to multiply it by the stuff that's on the inside. So I see 2 different objects in the parenthesis, and I'm going to connect each of them with kind of like this rainbow looking thing. So the first thing I see is the 3 and the A. Those are going to get multiplied, and it's always multiplication. The thing on the outside always gets multiplied by the thing on the inside. So 3 times A is just 3A. And since there was another thing inside the parenthesis, I'm going to connect that 3 to that other thing in the parenthesis, and I'm going to multiply those together. So a positive 3 times a positive 2 is a positive 6. And that's my answer. So I can take this stuff and shortcut it. If I can't add these 2 things together, because some stuff is letters and some stuff is numbers, what I can do is take the thing on the outside and multiply it by the stuff that's on the inside. And I can do this visually for you too if you want. 3A plus 2, what that really means is that there are 3 of these things. So if I have 3A plus 2's, I end up with 3 A's and 2, 4, 6. So again, the whole point is we don't want to be doing these drawings over and over and over again. So we're looking for shortcuts. Let me do another example real quick with you. So we've got 5, and I'll do like 4A minus 3, just so it's really, really clear. We take the stuff that's the outside of the parenthesis, and we multiply by the stuff that's in the inside. So I see 2 objects inside, and so that means I'm going to have probably 2 kind of rainbow-looking things, right? I'm going to take the number on the outside, multiplied by the first thing. So 4 and a are stuck together. It's not a 4 and an a, it's 4a together. So if I multiply those two things together, 5 and 4 makes 20. A just kind of comes along for the ride. And now once I'm done multiplying 5 and 4a, now I'm going to multiply the 5 with the other thing in the parenthesis. So 5 times the other thing is a -3. 5 times -3 is -15. And that's my answer this way. So all you need to do, short story style, is take this thing on the outside and multiply by all the stuff on the inside. If things are attached, you only worry about the numbers. Okay, so like 4a, we only multiplied the 5 and the 4. 5 and times -3, that's your -15. Okay, that's distributive property. So all you need to do now is look at this equation, or like this question, and figure out what matches. Do you think A and B are the same? Are A, B, and C the same? And you can highlight them the way that I did, or you can say like, I think A, B, and C are a match, and D and E match, or maybe you think A and D match, but not E. So however you want to write that up, take a look at the ones that you see and figure out which ones do you think are same but different. Like 5x and 2x is the same as 7x. These are equivalent, but they look different. So that's what we're looking for. Which of these are the same, but they look different? Hope that helps. If not, we'll practice some more on Friday.